Hi. Today I would like to discuss a question which came up in the recently concluded CBSE board exam of physics. And I'm sure you have seen this question, and it is also a previous year IIT mains or advanced, I'm not sure, that question. So it's a question from ray optics which involves the prism formula, geometric optics, not wave optics. So the question is to complete the ray diagram and to find the net angle of deviation. So this case we are given is we are given right angled prism with angle of prism as 60 degrees. We are given normal incidence to the hypotenuse face. Light is normally incident. It is passing through, and we are given the refractive index of glass to be √2. Now, bear with me. I have actually drawn a small part of the figure here. This is not given in the real question, but anyway, as I was drawing the normal line, I have drawn it here. As you all know, uh, normal incidence, there will be no refraction. Okay, refraction doesn't occur. Now, looking at the question, we are given or we observe that there's a mirror at the base of the prism, and the prism is a right angle prism, so we can mark the angle here. Or what I'll do is to differentiate between the answer and the question. I'll turn my pen into green. Yeah. So we understand this is 30 degrees. This is 90, so this will be 90 degrees. If this is 90 degree, this angle will be 30 degrees. Right. Now what we are supposed to do is we should draw the normal for this face. So let me put it in purple. Yeah. So I'll put it here. This is the normal at the point of incidence inside the prism. Clear? Yeah. Now, if this is the normal and this angle is 30 degrees, this angle here must be 60 degrees. Right. This is 60 degrees. Angle I1 equal to 60 degrees. We are given refractive index of the prism as √2. So, critical angle. Why are we concerned of the critical angle at all? First of all, it would be a good idea to note this because right in the question, right when you see the question, you understand that they are thinking about something relating to total internal reflection. Right when you see the mirror at the base of the prism, we understand it is something related to total internal reflection, because only if TIR occurs will the mirror play some part in the question. Now, if this is 60 degrees and angle I is 60 degrees inside the prism, and we are given √2 is the refractive index of the glass slab, we can calculate critical angle for the prism, and if angle of incidence I1 is greater than that critical angle, total internal reflection will occur. So for IC, that is critical angle, we apply Snell's law, that is n1 sin theta 1 equal to n2 sin theta 2. Here n2 will be surrounding medium air, and sin theta 2 for critical angle 90 degrees, so sin 90 is 1. So we know refractive index of air is 1, so 1 by √2 sin IC is 1 by √2 implies IC is 45 degrees. So critical angle for glass prism of refractive index √2 is 45 degrees. From this we infer that TIR actually occurs here, since the angle of incidence in this case is greater than 45. In fact, it is 60 degrees. So total internal reflection occurs. We have arrived at that conclusion. Now let me sketch the remaining part of the diagram. Since TIR occurs, it must occur at 60 degrees. So light would be reflected from that face at an angle of 60 degrees. So this is 60, and it will be incident on the base of the prism. Now we draw the normal at the point of incidence once again, and yes, let me move it here. This is the normal at the point of incidence. Yes. Now back to our pen. Yeah. Yes. This is 60 degrees. This is 90 degrees. So this must be 30 degrees. Right. This much is clear. And now we apply law of reflection, where the incident ray to this surface will reflect off the surface at the same angle of incidence, which is 30 degrees. So again, let me draw another line or another ray rather. So this will go here at an angle of 30 degrees. And will reach this face. Right. So this angle here is 30 degrees. Now, if this is 30 degrees, this angle here, the glancing angle must be 60 degrees, because this is the normal, right? So 30, 60. This is 60, this is 30. So it is a known fact that this is 90 degrees. And if this is 90 degrees, we get the condition for normal incidence, implies the light ray will pass straight through without any deviation from its mean path or original path, and hence light ray comes out like this from inside the prism. Right. So we have completed the ray diagram. So let me brush up. It comes in normal, hits the face, goes inside without deviation, without refraction. So the glancing angle will be 30 degree. I'll highlight it here. The glancing angle will be 30 degree. Then the angle of incidence, we can calculate it to be 60 degrees, which is greater than the critical angle of the prism, which is 45 degrees. Therefore, TIR occurs. Due to total internal reflection, the ray gets reflected and is incident on the mirror face. On reaching the mirror face, the angle of incidence will be 30 degrees, because this is 60, 60, 90, so 30. This will be 30 degrees. So angle of reflection will be 30 degrees. Glancing angle is 60 degrees. Therefore, the angle of incidence back on the hypotenuse will be 90 degrees. And due to normal incidence, the ray will pass straight out of the prism. So if we are asked to find delta net angle of deviation, net angle of deviation is the angle between the incident ray and the refracted ray or emergent ray. Emergent ray in this case is 180 degrees apart from the incident ray. It is not 0 degrees because the direction is opposite. Therefore, the final answer is delta net equal to 180 degrees or pi radians. I hope this is clear. Once solving the question, you understand that this is not exactly a very difficult question. It just involves multiple steps. Hope you enjoyed it. Thank you. Keep wondering.